my dear students. Today we are going to discuss about a chemistry lesson in grade 13. In grade 13 part, there are several physical units that has to be discussed. The first one that we are going to discuss is unit 11, chemical kinetics. Now, this is again really important lesson in our syllabus. So, let us see what are the reasons for the importance of this lesson. So, first of all, let us see the number of periods allocated for the unit. There are altogether 14 periods allocated for this unit. Therefore, you can understand how important this lesson is. And if you consider our A-level paper, in MCQ paper, you get 3 to 4 questions based on this unit. 3 is the minimum amount. In some of the years, you get more than 4 questions even. And if you consider the structured essay paper, sometimes you get this question based on structured part and sometimes you get this in essay part. If it is in the structured part, it will be our third question. We know that in our A-level paper, the third question is a physical question. And if you consider the essay part, sometimes we get this unit in the essay part. In such case, it will be only a part of a question in unit question number 5, question number 6 or question number 7. Now, make sure it is only a part of a question, not a complete question. So, you can understand this unit is really important in our syllabus. And the other thing is, when you answer the question based on unit 11 chemical kinetics, easily you can score full marks. Usually, when it comes to the essay paper, it's a question is about 75 marks. Normally, when students select this question, they can go up to maximum mark. That means, they can score about 75 marks out of 150 marks. So, you can understand this lesson is really important, and in our marking we have experienced there is a lack of selecting this question, but still we promote students to select this question because easily you can score mark. The reason for not selecting this question in the A-level paper is maybe they are confused with the theory part of the chemical kinetics. So, let us see in simple form what are the theory part that we have to learn under this unit. So, first of all, we are going to discuss about the first two competencies in the unit. The first one is about concept of chemical kinetics, and there we are going to discuss brief introduction about the chemical kinetics, and the second one is rate of a reaction. How do we define rate of a chemical reaction? So, there are so many things that has to be discussed under this unit. Let us see what are those. Now, these are the important topics that we are going to discuss in this unit. We need to discuss the rate of a chemical reaction, and also we are supposed to discuss theories of reaction and factors that affect reaction rate and mechanisms and effect of concentration of rate and how to estimate the reaction rate depending on the reaction and half-life. So, these topics will be discussed under chemical kinetics unit 11. And of course, there are a lot of new terms. Now, these terms you never get in previous lessons. So, these terms will be you get only in kinetics, chemical kinetics. So, once you finish this unit, you may able to define and you may able to get the clear meaning of these terms. So, let us see what are these new terms. Reaction rate, collision theory, collision rate, collision frequency, effective collision, successive collisions. Actually, the effective collision and successive collision terms are same, and activation energy, transition state, activated complex, again transition state and activated complex will be same, intermediate, rate low, order with respect to a reactant, rate constant, half-life, molecularity, elementary reaction and complex reaction. So, once you finish this unit, not the today's lesson of course, once you finish this whole unit, you may come to know the exact definition of these new terms. So, let us see the important aspects of this chemical kinetics. Why do we need to learn about chemical kinetics? if you consider any chemical reaction, there are three important aspects. The first one is feasibility of the reaction, and that will be discussed in unit 5 under energetics or thermodynamics, which you had already done. The second one is, the second aspect is the extent of the reaction, and that will be discussed in unit 12, equilibrium unit, which you have to discuss after this unit. And now we are going to discuss about the rate of the reaction, and that only we are going to discuss in this unit 11, chemical kinetics. So, these are the important aspects of any chemical reaction, and we are going to see more details about these three aspects. Now, this feasibility part is already discussed in unit 5 under energetics. So, what is feasibility? Sometimes we call this as spontaneity, and it is given by delta G of the reaction. How do we calculate the delta G? In unit 5, you had learned about how to calculate delta H, that is enthalpy change, how to calculate delta S, that is entropy change, and how to calculate delta G. We know that there is a direct relationship between delta G, delta H, and delta S as given in this equation. So, considering this equation, if you know the enthalpy change of a reaction, which is delta H, and if you know the entropy change of the reaction, which is delta H, delta S, and if you know the temperature that reaction take place, you can easily calculate the delta G, that means the Gibbs free energy change, to find out the feasibility or the spontaneity of the reaction. And also in unit 5, we have learned if delta G is a negative value at constant temperature and at constant pressure, then the reaction is feasible. That means the reaction will be spontaneous. Now, even though the reaction is spontaneous, it does not give, we came to know that disadvantage of the delta G is it does not give any idea about the rate of the reaction. So, that is why we are going to discuss reaction rate in this separate unit. So, if the delta G is negative for any given reaction, the reaction will proceed under the given condition. That means, under given direction, the reaction will proceed under that particular temperature. We will see one more example later on. The extent of the reaction. Extent of the reaction will be discussed in unit 12. In unit 12, there is an important term called chemical equilibrium. There are several chemical equilibrium terms, Kc and Kp. I had given here the definition of Kc because it is easy. And if you are provided with a certain reaction, you can see a reaction, generalized reaction is given, how to define Kc. The importance of Kc is whenever Kc is greater than 10 to power 3, we say the reaction is towards product direction. That means, if you consider the medium under this condition, always it consists more products than reactor. So, that is the importance of equilibrium constant. So, that is also necessary to get certain idea about the reaction. Even though reaction is feasible, sometimes you may need to have less amount of products or less amount of reactor. So, that is given. The extent of the reaction is given only by the equilibrium constant. So, in this unit, we are going to discuss about the rate of the reaction. And what is the importance of the rate of the reaction? We should know whether the reaction is fast or not. When we do practicals in our lab, sometimes you may have experience, you are waiting for long time after mixing reaction, we couldn't get observation. That is because the rate of the reaction is low. So, we need to know how to speed up this reaction. In such case, so we should know more details about the rate of the chemical reaction. Normally, whenever the reaction occurs slowly, we say the reaction rate is low, and if the reaction is fast, we say the rate is high. Now, if you consider day-to-day examples, why do we need to know the reaction rate? There are some day-to-day applications in the reaction rate. If you consider a chemical industry, most of the things that we use in day-to-day life are made by chemical industries. So, in such case, we need to get the product within short time period. So, whenever we need to get the product within short time period, we should know how to increase the reaction rate. So, then we should know what are the factors that affect the reaction rate. The reaction rate depends on concentration, pressure, physical state, catalyst and temperature. So, these are the factors that affect reaction rate. So, if you know the exact factors that affect the reaction rate, easily you can change the reaction rate as you want. In some of the situations, especially in industrial aspect, we need to increase the reaction rate. So, by changing these factors, we can control the rate as we want. In industry, actually we need to increase the reaction rate because we need to get the product within short time period to minimize the production cost. So, one example, rusting of iron. If you consider the rusting of iron, it will take long time. If you put a nail into atmosphere, you won't be able to see that it had been undergone rusting in 2-3 days. It will take weeks, maybe it will take months, or maybe it will take years. It depends on the moisture or the humidity of the air. So, in certain situations, we need to minimize. Actually, it is a slow reaction. If you consider this rusting is naturally a slow reaction, but certain situations we need to prevent that. Even though it is a slow reaction, sometimes we need to prevent that. And in your O-level knowledge, you know how to prevent the rusting. What are the methods that we can prevent rusting? We can prevent rusting simply by applying grease, or by applying oil, or by applying paints. Now, let us consider this example, conversion of diamond into graphite. Do you think whether it is feasible or not? So, let us see whether it is feasible or not by applying our chemical knowledge. This reaction, the conversion of diamond into graphite, is exothermic reaction. We know that in exothermic reaction, delta S is negative. How do we identify exothermic reaction? By the sign of this delta H. It is a negative value. And if you consider conversion of diamond into graphite, we say entropy increases. Why do we consider that entropy increases? Delta S is a positive value. Now, why do we consider entropy get increased? The reason is in the diamond, carbon is connected to 4 other carbon atoms. That means the carbon will be at its maximum valency. When it comes to the graphite, each carbon is converted only into 3 carbon atoms. So, then there will be 1 non-bonded electron. Because of that, entropy increases. So, if we relate these two terms with delta G, we know that delta G equal delta H minus T delta S. Here the sign is negative, here the sign is positive. The multiplication of the two will be negative, where we get a net value for delta G. So, easily you can understand, as you had done this delta G in unit 5, if the delta G is negative, the given reaction is feasible. That means the given reaction is feasible only thermodynamically. What about the kinetic aspect? That only we are going to discuss in this unit. Even though the reaction is thermodynamically feasible, the reaction rate is very, very slow. There is a reason for that, but I am not going to explain the reason now itself. We can discuss that later on. So, we will see when we do this lesson what is the reason for the low rate of this reaction. Thermodynamically the reaction is feasible, but kinetically the reaction is not feasible. So, we do not want to take any actions to prevent the conversion of diamond into graphite. Naturally, even though it is feasible, it does not take place. Another important example, something relevant to the reaction rate, is food spoilage. Now, we know that we have so many experience regarding this food spoilage. We need to prevent this, or at least we need to minimize that. So, how do we minimize this reaction rate? It is a chemical reaction, actually a series of chemical reaction. How do we minimize the reaction rate? So, easiest way, there are so many methods we came to know. There are certain factors that affect reaction rate. Of course, you can control those, but the easiest way to minimize or to slow down the reaction rate is simply keeping the food in the refrigerator. So, what are we going to do by keeping the food in the refrigerator? We are going to lower the temperature. So, one method we can reduce the reaction rate by lowering temperature. That can be done by keeping the food in the fridge. So, this is a moderate reaction when compared with the previous example. where I told those are slow reactions. These can be slowed down by keeping in refrigerator. So, let us see the difference between ionic reactions and covalent reactions. Okay. First of all, let us discuss what are ionic reactions and covalent reactions. What are the ionic reactions? Ionic reactions mean the reaction involves with ionic compound, and covalent reactions mean simply the reaction involves with covalent compounds. Now, if you compare these two reactions, they are having two different rates. The reason is they are bond in nature. Ionic compounds are having ionic bonds, where the compound is made up of cations and anions. If you consider the covalent compounds are made up of covalent bonds, where the multiplicity of the bond can be either single, double or triple. Depending on that, the reaction rate will be different. So, first of all, let us consider the ionic reaction. In ionic reaction, usually these are fast reactions. The reason is ionic compounds, at the moment you add these into water, they will completely ionize. Actually, we call those as strong electrolytes. You may learn about more details about this term strong electrolytes in unit 14. So, strong electrolytes mean they will completely ionize in aqueous medium. So, if they completely ionize to cations and anions in aqueous medium, simply they can colloid with each other to give product. That is why these are fast, and there is no necessary of breakdown of bond during the reaction, because already we have separate cations and anions in the medium, and reaction rate reactants can colloid with each other easily, because already we have separate ions. So, that is the importance of ionic reaction. Not all the ionic reaction, most of the ionic reactions are fast due to this reason. When it comes to the covalent compounds, it is other way. In covalent reaction, usually these are slow. What is the reason? There will be so many bond breakdown and bond formation during the reaction. If you consider any covalent reaction, while they undergo reaction, some of the bond will break down and you are getting some new bonds. So, this formation bonds and breakdown of bond involved with complex bond rearrangement, which require lot of energy and which require lot of time. Because of that, these are slow reactions. So, reactions involved with several bond breaking and forming, these are all the time involved with several bond breakdown and bond forming. So, they can undergo reaction. Ionic compounds can covalent compounds can undergo reaction if they undergo a bond dissociation, then only they can undergo reaction. One simple example, if you consider the atmosphere, we know that our atmosphere is mainly composed of nitrogen and oxygen, but why do not they react? We know that oxygen is a combustible substance. It can easily react with nitrogen to give NO or NO2 or any other nitrogen oxide, but why don't they react with each other in the atmosphere? The reason is the nature of the bond. If you consider the nitrogen molecule is made up of two atoms, where the two atoms are connected with each other through a triple bond, and if you consider the oxygen, it consists a double bond. So, during the reaction, if they undergo any chemical reaction to form any kind of oxide, definitely the triple bond in the nitrogen as well as the double bond in the oxygen has to be broken down, which will require lot of energy. So, it requires lot of energy and also it will take longer time to proceed the reaction. That is why it does not react at room temperature. At room temperature, if you consider atmosphere, nitrogen and oxygen will not react, but we can convert those into reactive form by changing the temperature. We will discuss more details in a later chapter. So, if we consider a covalent reaction where we get lot of bond dissociation and bond formation, always those reactions will be slow reactions, and if there is no that much bond dissociation or bond rearrangement during the reaction, in such case the reaction will be faster even though it is a covalent reaction. So, we will discuss more details later on. And why these reactions are having different rates? Now, rate is something relevant to time. If you consider these reactions, We can classify all the chemical reactions into 3 categories depending on the time required to proceed the reaction: instantaneous reactions, moderate reactions and very slow reactions. There are 3 types of reaction depending on the time required to occur the reaction as instantaneous reactions, moderate reactions and very slow reactions. So, the example that I had given is, can you all identify the reaction from the color? It is the reaction between iodine and starch where you get the blue color complex. Actually, the initial one is not iodine, otherwise the solution cannot be colorless now. So, but if you get iodine by a certain reaction which take place in this container, and that iodine can combine with starch to give blue color. So, this blue color will appear within certain time period depending on so many factors, and that is also very important reaction that we are going to discuss under chemical kinetics. So, again later on we will discuss more detail about that reaction. So, we came to know that there are 3 reactions depending on the time. First of all, we will discuss about instantaneous or very fast reactions. Now, from the name itself you can get idea. Instantaneous or very fast means the reaction take place within short time period. Actually, once you mix the 2 reactants, at that time itself the reaction will proceed and instantly you can see the observations. So, these reactions occurs as soon as reactants are brought together, and usually the reaction will complete within fraction of seconds, and it is impossible to measure rate of this kind of reaction because the reaction will proceed or finish off within short time period. Actually, even though we can't apply normal measurements to find out the reaction rate, there are many modern techniques that you can use to get the reaction rate even in this kind of reactions. So, what are the examples for this instantaneous reaction? Simple examples are given here. The first one, explosion of a bomb. Explosion of a bomb is instantaneous reaction. The reaction take place within fractions of second. Another example, same type, nuclear reaction. Nuclear reaction will take place within very short time period where we get large amount of heat and so many other particles. Another example which is really important in chemistry, the reaction between silver nitrate and sodium chloride where we get silver chloride white color precipitate. You can see from the diagram, you know that silver chloride is a white color precipitate. At the moment you mix these two, but make sure you have to use concentrated solution. If you use concentrated silver nitrate and concentrated sodium chloride, at that time itself when you mix the 2 reactants, you can see the white color precipitate. Another example for instantaneous reaction, the reaction between HCl and sodium hydroxide. HCl is a strong acid, sodium hydroxide is a strong base. So, these two will undergo a chemical reaction known as neutralization. So, in such case quickly you can get the observation. What is the observation? Nothing can be seen because HCl also colorless, sodium hydroxide also colorless. Our products, the 2 products sodium chloride and water are also colorless. So, there is no color change in the reaction, but there are several other physical parameters that we can consider. During the reaction, there is a change in the temperature, there is a change in the conductivity of the medium, there is a change in some other physical parameters. So, one of those can be measured to get idea about the reaction rate. Not all the neutralization reaction. Now, this is very good example for instantaneous reaction. After we will discuss all the 3, we will see one important example which we can use in all the 3 reactions which we had learnt in organic. So, the second type of chemical reaction is moderate reaction. Again from the name itself you can get idea about the reaction rate. Now, most of the reaction that we get in day to day life or most of the reaction that we do in our chemistry lab will be moderate reactions. So, it will take certain little time to get the observations. Once you mix the 2 reactants, it will take certain time to undergo certain bond rearrangement and to see the product. So, rate of these reactions easily can be monitored at room temperature. One simple example that we can observe is the reaction between calcium carbonate and HCl. The calcium carbonate and HCl will react to give calcium chloride, carbon dioxide and water. Now, what is the easiest thing that we can observe during this reaction? The effervescence. When you add the acid to the calcium carbonate, you can see a sudden release of carbon dioxide. So, that only effervescence. So, you can see effervescence during the reaction that can be monitored as a function of time, whether you are getting the effervescence within short time period or longer time period. Now, since this is a moderate reaction, it will take certain time period to see that effervescence. The second example is decomposition of hydrogen peroxide. Actually, this reaction does not take place at room temperature. To get done the reaction, there are several things that we can do. One thing is we can use sunlight. Sunlight can induce this decomposition. The other thing is we can use a catalyst. Now, here I had given example catalyst, a certain enzyme is used to induce the reaction. There are so many other chemicals that you can use in the lab. You can use manganese dioxide simply as the catalyst for the reaction. At the moment you add little bit of manganese dioxide powder to the hydrogen peroxide, you can see sudden bubbling of oxygen. The evolved oxygen can be collected. Another example for moderate reaction is easily, I know this will be a familiar reaction in biology. Bio students know this reaction very well. What is that reaction? It is the hydrolysis of sucrose. We call it as hydrolysis of sucrose. Sucrose will break down into two simple sugars known as glucose and fructose. So, this is again a moderate reaction where we can measure the reaction rate easily. Another well known example in our chemistry lab, the reaction between thiosulfate and HCl. You can use of course any thiosulfate, but normally in the lab we use sodium thiosulfate. When we add a dilute acid to sodium thiosulfate, you get sodium chloride, colloidal sulfur, sulfur dioxide and water. Now, what we can measure as the reaction? Now, from the diagram you can see with the time, now the given colors depending on the time, with the time you can see at the last one you get a yellow color. We call it as a milkiness. Can you all remember that term? We call it as a milkiness. Milkiness will appear once the reaction is over. So, we can measure the time required to appear this milkiness. So, this is a moderate reaction easily where you can detect the time. Another example is the reaction between ferric chloride and potassium iodide. Ferric chloride and potassium iodide will react to give ferrous chloride, potassium chloride and iodine. How do we identify the evolved iodine? There are so many methods. When iodine, once it is formed in aqueous medium, it will appear in yellow color. But the identification of the yellow color will be difficult because already medium consists ferric chloride which is reddish brown. So, rather than considering that yellow color, we can go for certain intense color change during the reaction. One example, you can add small amount of starch to the medium. In the presence of starch, iodine will combine with starch to give intense blue color complex as you can see in the diagram. So, we can monitor the time required to appear the blue color as the reaction rate. So, those are the examples of moderate reactions. The last type of reaction which depends on the time is very slow reaction. Again from the name itself you can get idea whether it is fast or not. This is a very slow reaction. It will take very long time to appear the observations. Sometimes actually you can consider the reaction won't take place at room temperature at all. So, it is very difficult to study again kinetics of these reaction because we have to wait for days or maybe for months or maybe for years to get the observation. Because of that, the studying of kinetic of these kind of reaction will be very difficult. Now, one such example is the reaction between hydrogen and oxygen. Hydrogen and oxygen will combine to give water. In energetics, we have learned this reaction is highly exothermic. Even though reaction is exothermic, it does not take place. What is the reason? Just by considering the delta H, we came to know we can't predict the spontaneity or the feasibility of the reaction. To predict about the feasibility, we should consider the delta G. So, this reaction, even though it is exothermic, does not take place at room temperature. If you mix hydrogen and oxygen, you can't see any observation. You can't see that liquid water is formed. But if you want to induce the reaction or if you want to increase the reaction rate, in such case we can do several things. One thing is you can use a catalyst or you can heat the hydrogen and oxygen mixture. As the catalyst, there are so many things that we can use. One simple example is small amount of platinum powder can be used as the catalyst. Another example for slow reaction is the reaction between carbon and oxygen, where we get carbon dioxide. If you consider the combustion of graphite, if you expose graphite into atmospheric oxygen or just the normal air, it does not catch fire. The reason is the reaction rate is very low at room temperature. But of course, we know that we can burn the graphite, that is at a different temperature. If you convert the graphite into a ignition temperature, then easily it will catch fire. But at room temperature, this is a very, very slow reaction. So, these are the three types of reactions that we learn depending on the reaction rate. Again, if we go for the beginning of that part, we came to know we can classify the reactions into three categories depending on the time required to get done reaction. There is a special type of reaction which we had learned in organic chemistry. You can categorize the same reaction under three type of reactions. Can you all remember that reaction? Now, as you already done organic chemistry, you may know this example. That is the identification of alcohol with Lucas region. If you consider the identification of alcohol with Lucas region, depending on the nature of the alcohol, it will take different time to get the cloudiness in the medium. In this reaction, we know that there will be a cloudiness during the reaction. The time required to appear the cloudiness can be used to classify the reaction into three categories. If you consider the reaction between tertiary alcohol and Lucas region, it is instantaneous reaction. Can you all remember that? Tertiary alcohols immediately react with Lucas region to give the turbidity or the cloudiness. When it comes to secondary alcohol will give the turbidity maybe about 3 to 5 seconds at room temperature. So, that can be considered as a moderate reaction. The reaction between secondary alcohol and Lucas region can be considered as a moderate reaction. When it comes to the reaction between primary alcohol and Lucas region, actually it will take very long time at room temperature to get this turbidity. At the room temperature, it may take about more than half an hour to appear the turbidity. So, we consider that reaction does not take place at room temperature if you consider the primary alcohol. That is why it is categorized under very slow reaction. So, that is very good example where the same reaction, we get the same reaction, but you can classify depending on the nature of the alcohol into three different reactions. Now, let us see how do we define the reaction rate. When it comes to rate, we can understand from the name itself, it is something relevant to the time, something relevant to the speed. So, generally we consider speed as the change in the distance per unit time. But what about the reaction rate? If you consider a reaction, we can't consider a change in the distance. So, then what we are supposed to consider as the physical parameter that we can use to express a factor which relevant to the time, that is only the extent of the reaction. When it comes to chemical reaction, the reaction rate is defined considering the extent of the reaction. To how extent we get the reaction within given time period. So, let us see how do we define the reaction rate. Simply it is defined as Rate of the reaction is the change of the amount of reactant or product per unit time. Of course, you can consider either reactant or you can consider the product. It is okay to consider one of them. It depends on your choice. And the other thing is you need to consider the change in the amount. What is the amount? We know that in chemistry amount is the number of moles. So, simply you can consider the change in the number of moles of reactants or products, something relevant to the time. So, we defined it as rate of reaction is the change of the amount of reactant or product per unit time. So, if you need to get mathematical expression for the rate, that is R equal the change. To denote change in chemistry, we use the sign standard symbol delta, n is used for the amount. So, then delta n over delta t. Rate is defined mathematically. In mathematical form, it is defined as R equal delta n over delta t. So, R is the reaction rate, delta n is the change in amount of reactants or products. Actually, that is the number of moles of reactant which had been undergo this changing or the product, and delta t is the time required to get done this reaction. We know the unit of amount of substance is mole, which we symbolize as mol, and time is measured in second, simple as. So, then according to this definition, the rate has the unit mole per second. Now, in such case, the rate can be defined as mole in mole per second. There is another way to define that. Okay. Now, how do we get the change? We came to know that you have to consider the change of the number of moles per unit time, change of the number of moles in given certain time period. How do we get the change? To find out the change, always the standard method is not only number of moles in any physical parameter. Whenever you want to find out the change, something relevant to the chemical reaction, always you need to deduct the initial one from the final physical property. Always you have to deduct the initial one from the final one. So, to find out the change, deduct the amount of initial one from the final one. Whether it is reactant or a product, the definition will be same. Always we get the delta n by this difference. But the problem is, if you consider the reactant, when reactants are considered, always initially we have more reactant. With the time reactants are consumed now, then reactant amount get decreased. That means always the final value with respect to the reactant will be a smaller one, whereas the initial value with respect to the reactant will be a larger one. So, if you consider the difference, now difference is the change between or the difference between the final and the initial, now you will end up with a negative sign. Whenever if you consider a reactant, to get the change, you will end up with a negative value for delta n. But we know the reaction rate cannot be a negative one. Always in any kind of chemical reaction, the rate should be a positive quantity. So, to convert this into positive quantity, to convert the change in the number of moles into a positive quantity with respect to rate, we have to make a trick. So, let us see what you are supposed to do. So, that is the trick. Now, here a simple reaction is given, a conversion of A into B. So, our A is the reactant, B is the product. So, in such case, you can define the rate either with respect to A or with respect to B. Now, if you consider the A is our reactant. So, if you are going to get the change or the difference of the A, initially we have more A, with the time the amount of the A get decreased, therefore, the difference will be a negative value now. To convert that into a positive quantity, when it comes to the rate, we multiply that difference by a negative sign. We multiply that by a negative sign. So, then rate will be a positive quantity. So, always whenever we define the rate with respect to a reactant, make sure to multiply this difference by a negative sign, where you will end up with a positive quantity for rate. And what will be the unit? Already we came to know the unit is mole per second. But if you consider a product to define the rate, no need to consider that negative sign, no need to use that negative sign, because already at the beginning of the reaction the amount of product will be 0, finally we get more product. That means always the final value will be a larger one when compared to the initial value. The difference between the two is a positive quantity. When it comes to the product, if you consider this reaction, when it comes to product, always we are having a larger value for the final one and lower value for the initial. Actually, of course, it will be in most of the cases 0. So, then you will end up with a positive quantity for delta n. If it is a positive quantity, so no need to make any changes during defining the rate. So, with respect to a product, our product is B. R can be defined as R equal delta NB over delta T. Here again the unit will be mole per second, because we are considering the amount change in the amount of substance. Now, if you consider a reaction take place in solution, what is the difference between solution and another reaction? Always in a solution we assume the volume, total volume of the system will be a constant. Of course, there can be slight changes when you get a precipitate or when you get a displacement reaction, there can be a slight change in the volume, but it is negligible. In such case, or if you consider a gas phase reaction which occurs in a rigid container, if you consider a gas phase reaction which occurs in a rigid container, then again volume will be a constant. In such case, instead of the number of moles, we can easily consider the concentration. We can see from this equation the number of moles or the amount of substance is directly proportional to the concentration. In such case, we can use the term concentration instead of the amount of substance. Now, how do we define the rate? According to this situation, we can define the rate as the rate of the reaction is change of the concentration of reactants or products per unit time. Again, either you can consider reactants or of course, you can consider the product, but make sure now we are considering the concentration, but not amount of substance. So, if you are going to define rate with respect to concentration, now how do we get the mathematical expression? The mathematical expression will be R equal delta C over delta T. Delta C is the change in the concentration, R is the reaction rate, delta C is the change in the concentration either with respect to reactant or with respect to product, and delta T is the time required to get done the change. And what about the unit? Concentration is measured in mole per decimeter cube and time is measured in seconds. Then the rate, unit of the rate will be mole per decimeter cube per second. So, let us see a real example. Now, again I am considering the same simple reaction where A converts to B. A is our reactant, B is our product. So, if you are going to define rate with respect to reactant, now we are going to consider the change of the concentration of A. Again we get the same problem. Initially we have more A, then the initial concentration of the A will be larger, and at last that means the A is consumed and then concentration of A decreases. Therefore, the difference will be a negative value. If you consider the change of the concentration with respect to A, it is a negative value, but already we came to know the rate of a reaction cannot be a negative value. So, to convert the rate into a positive quantity, again we multiply that value by a negative sign. But make sure this has to be done only with respect to reactant. Then unit again of course will be same as we discussed. But if you are going to define the rate with respect to product, now our product is B. If you need to define the rate with respect to B, now no need to use this negative sign. What is the reason? Initial concentration of B of course almost 0. We are not having the product B. With the time we are getting more and more product. That means the final concentration of the B increases. So, if you consider the difference between initial situation and the final situation with respect to product, already we are having a positive quantity. So, if you have a positive quantity, then When you divide it by the required time, you will end up with a positive quantity. So, R is already a positive one. That is why we do not use this negative sign with respect to product. Again the unit will be same as earlier, mole per decimeter cube per second. What about a gas phase reaction? What are gas phase reactions? Gas phase reactions are reactions where you get only gases. The reactant as well as product will be a gas. In such case, instead of the concentration, we can consider the partial pressure. We can consider the partial pressure of either reactant or a product. So, then rate can be defined considering the change in the partial pressure. So, then rate of the reaction is the change of partial pressure of the reactant or product per unit time. Of course, again you can consider the partial pressure of reactant or product. So, then mathematical expression will be rate is equal change in the partial pressure over the required time. The pressure as a standard is measured in Pascal. Of course, you can consider any other unit. The time is measured in second, then the rate is given in Pascal per second. Now, again let us consider the same example, thinking that this is a gas phase reaction. In such case, again we can define the rate either considering A our reactant or considering B our product. So, then rate can be defined with respect to A. If A is a gas, we can consider the change in the partial pressure of A. Initially we have more A, then its partial pressure will be larger. With the time A is consumed, then the partial pressure of A decreases. So, what you get as the change with respect to partial pressure of A is a positive quantity. So, then to convert rate into a positive, what you get as the change with respect to A is a negative value. To convert that into a positive quantity with respect to product, with respect to rate, you need to multiply this change by a negative value. You need to multiply this one by a negative value. So, then you will end up with a positive quantity for reaction rate. And again you can consider the pressure, you can consider the partial pressure of product even. Our product is B. Initially B is not there now, then initial partial pressure of B, which is our product, will be 0. With the time we are getting more and more B, the amount of product get increased, then the partial pressure of product B increases. So, as the difference you get a positive quantity. Already it is a positive quantity. So, no need to multiply by any negative value. So, then unit will be same as already we discussed, Pascal per second. We will discuss more details about how to define reaction rate considering real examples in next lesson. Now, here I had given only imaginary reactions, a simple, very simple reaction considering conversion of A and B, A into B, where we have only one reactant, where we have only one product. As in this given example, there is only one product and one reactant, but when it comes to a complex reaction or depending on the nature of the medium, whether it is a aqueous one or a gas phase one, where you have several different physical state in the same reaction, let us see in next lessons how do we define the rate. So, that is all about today's lesson. The most important part that we discussed today is how to define the rate of a chemical reaction. To define the rate of a chemical reaction, what you have to do is you need to consider a change in physical quantity. You can consider either the amount of substance, that means the number of moles, or you can consider the concentration, or you can consider the change in the pressure. It does not matter, whatever the physical quantity that you consider, you can consider that change either with respect to reactant or with respect to a product. You can define the rate of the reaction per certain known time period. There are so many methods to define this rate. We will discuss all those things in the next lesson. Thank you.